Hi, my name is Joe. Welcome to my shop. This is the three-phase Liberty bunker, and today we're talking about the miter buddy. So I made a 1-minute long video about this in the past where I explained just an overview and I showed some clips of it in use, but I wanted to talk more about all the design thoughtfulness that I put into this, and I also wanted to show specific machine setups, slitting saw, hole saw for notching the end of the tube, and how to get the most out of the machine and the most out of the product. Here it is. This is the miter buddy in its true home on a Kurt style vise, 6-inch milling machine vise, sitting atop a Bridgeport milling machine. So whether or not you have a Bridgeport brand, this style of vertical milling machine I think is really valuable for a lot of things, especially for a frame builder. This kind of machine is what I designed it for. So you can use these on a horizontal milling machine where the spindle, instead of running up and down like this and spinning in this direction, the spindle comes out this way. And those machines are great for a lot of things. That's not what I designed this tool for, and I've seen people use the tool that way. It certainly can be used that way, but you know, the idea is that the jaws are parallel with the x-axis of your machine, and then you can pivot the tool to set the angle of your cut like this. And so if you're using it on a horizontal milling machine and the spindle's coming this way, the only way that you could really, you know, adjust the angle of cut is if you had your vise spun this way, and now it's just kind of a screwier way to go about doing it. It's hard to have the full range of adjustment. And so this really is meant to hang out of the side of a vise on a vertical milling machine, was sort of the intended application of this thing. And I say a Kurt style vise because for a number of reasons. I mean, this is just the vise. You know, it's a great vise for a manual milling machine. But also, I made this pin here. This is a 3/8 diameter pin, and it fits beautifully in this 3/8 hex socket on this cap screw. And so if you don't have a Kurt style vise, you can just remove that. There's a little set screw in here. But if you do have one, then when you set it in there, and now you're setting the angle of your cut, right? All you got to do is just kind of bump it around, and it stays elevated from the bottom of your vise where you might have chips, and it's not just, I think it makes adjusting it just kind of nice. And so I wanted to include that feature. So yeah, I mean, you set it up in the machine, and then you put in either, you know, if you're doing a slot and tab style dropout method, then you might use a slitting saw. And if you're using right style hooded dropouts, round dropouts, you might use a hole saw like this. I suppose you could also use this for drilling holes in certain applications, and you'd have to set it up carefully and whatever. You know, there's sometimes you want to hold a tapered tube, and you could use this for an operation, but generally I designed it for just preparing the dropout end of a seat stay or a chain stay where you have a tapered tube, or possibly even where you had a round tube that had an ovalization to it, like if you had a titanium straight gauge tube and you maybe squished the end of it ovalized to fit onto a right style dropout, round dropout, you know. Yeah, so let me demonstrate how this thing works. You load your tube in and you tighten down the screws. You put it in the vise, and now you want to set your angle. And I like to use a digital angle gauge like this. So these guys are great because they're pretty cheap. I picked this up for $35, and it resolves, I think, enough accuracy for the task at hand. You know, you could use a sine bar or something if you were really getting fussy, but there's a pretty small cross section here. This is, you know, 15 millimeters or something, even on this one, which is a little bit large. And so, you know, from one side to the other side, if you do the trig, the difference actually, if you were to be off half a degree or something, you would have just a very tiny gap there to fill with your weld. And so, I mean, you have to be off a fair amount before it's going to create issues, and I feel like these resolve enough accuracy that that's not a problem. So I like to set it on the top of the tube, and now you just set your angle by loosening the vise and tightening it until you're happy with what you're reading. And in order to know what you want that inside face of your chainstay or seat stay angle to be, you need to draw that up, full scale drawing on paper, or you could model it in 2D or 3D CAD software. Or what I always did in the past was I would use bike CAD software, which I already had. It's maybe not the most sophisticated for modeling the rear end of a bike with ovalizations and tapers and multiple bends and things, but you can certainly get the job done well enough for this. And so whatever method you choose, you just need to set up your tube. And then the beauty of it is you can just grab your wrench here, 6mm wrench, and you loosen this up, and then now you pull your tube out, you put in the next tube, and you have the same angle already established. So you can make repeat cuts to the same angle, which I think is a nice convenience feature that's built into this. As long as you don't loosen the vise, it'll stay put. We talk about some more design features. There's a couple reasons that I gave this a 3-inch wide proportion. I wanted this to be 3 inches wide for a couple reasons. One reason is that if you have a vise that is not the Curt quality vise, you might have issues where when you go to tighten the vise, this moving jaw really wants to cock sideways. And what happens when that's going on, if you put something in the side like this, it's going to pinch kind of right here. The moving jaw is going to pivot, and it's really only going to be grabbing here, and then it's going to want to swing around. It's really not held very well. And so people will commonly use a packing block, which is why I picked this up. These are 1, 2, 3 blocks. You can buy a set of these cheapies for like $10. There's also other things you might have in your shop that happen to be exactly 3 inches wide. And so you set this on the other side of the vise, and you put this on this side of the vise, and now when you tighten it, this is if you had like a drill press vise or something that was real cheap and floppy, your screw is pushing down the center line, and you have something on either side, and so now these jaws are going to be parallel to each other, and you're going to get good bearing across the faces of the tool, even if your vise is not such a nice vise as this one is. And like I said, you can just remove that pin if you don't need it, so that allows you to use a wide variety of vices. You don't need to have this nice, made in USA machinist vise in order to use the tool. The other reason that I made it exactly 3 inches wide is that you can set up this vise on your machine, and you want to get this rear jaw trammed straight with the x-axis of the machine. And once you've done that, you can use an edge finder, like this guy here. And if you touch off on this face, you know that the center line of your tube is 1.5 inches away from that. So we'll demonstrate that. So with the edge finder loaded in the spindle, we know the tip diameter is 200 thousandths of an inch. And so if we get it touched just against this face, that means that we're half the diameter, which is 100 thousandths, off of this face. So I'll spin it here at about, this is 1100 RPM, 900 RPM works well for this. Anywhere in that range, just above or below 1000. And right there, it kicks off. There's a spring on the inside of this. There's a spring, and there's these 2 lapped faces. And when you just touch the edge, there's enough drag from this tip, it pushes the end sideways. And so if I'm looking at it from this direction, I can really see that. I'm feeding in slowly. And right there, it kicks off to the side. That's when I know that I'm 100 thousandths of an inch away from this fixed jaw. And I can zero out my digital readout if I have one. Or, if I don't, you use the old school method where you have the dials, and you have to zero your dial to whatever number you want. And then you have to count revolutions, and you have to account for backlash, which is more of a pain, but certainly a good way to get the job done. You can be plenty accurate for the task at hand using those methods. So now that I've touched off of this edge, I'm going to move over 100 thousandths of an inch, because I know that's the distance that I was from the actual being on the center line. Now I zero that, and now if I just crank over 1.5 inches, now we're on the center line of where the tube is going to sit. So now I can load in my hole saw, make a cut, and I know that regardless of what I change the angle to, and regardless of the diameter of the tube, and regardless of how many bends it has in this axis, I'm still going to be on the center line here. One of the reasons that I love a Bridgeport style milling machine for mitering is not only is it a versatile machine that can do a lot of miters, and it's useful for a lot of things outside of only mitering, but in the frame building shop, it's great also because it has power feed on the Z axis here. And so when you engage the worm gear, and now I'm set for 3 thousandths of an inch down feed per revolution according to this gearbox on the side. So when I turn on the spindle and I want to make a cut here, I know I'm on the tube center line. I'm going to lock the table so it can't move around. I'm going to lock the vise. This is a pretty steep angle. Let me lower that angle some. Now we can make our cut. This is 660 RPM. And so by pulling this lever out, now it's going to feed the cut for me. So there's no guesswork of getting the cut on center, even though the tube is tapered. I used to make a different tool that allowed you to hold a tapered tube, and the center line of the tube actually was not parallel with the x-axis of the machine, and so getting the cut on center line was just a little bit more tricky. But with this one, it's very easy, which is why I changed my design toward this. Yeah, and so, you know, the tube can be larger or smaller, stick out further, come back. You can change this diameter cutter, and it's still always going to be on center line if you know that you're 1.5 inches off of this fixed jaw face. All right, so now you want to make a cut with a slitting saw for your tab style dropout, right? So you want this to fit nicely and tightly, whether you're welding it or usually it'd be brazed, right? You want it to fit in there nice. And so again, the same way you're going to put the tube in with the same orientation, you're going to set your angle the same way with your digital angle finder. And now you want to make your cut through there so that the slot width ends up being the same as the tab width, you know, plus maybe a couple thousandths for clearance. And so I like to use an 1/8 inch slitting saw. It's 125 thousandths of an inch. And then you use calipers and you measure the thickness of the tab, right? So this one here is like 196 thousandths. So right, I want my cut to come in sort of like that. Right? I don't want to go too low or too high. I don't want to feed in too far, but that's basically where I want my cut to take place. And so what I like to do, I know this is 125 thousandths and I know I'm going for 196 thousandths, so I subtract the two. I make one pass all the way at the top of the cut, or else all the way at the bottom of the cut, and then I finish by just moving up or down the appropriate amount to finish the cut. And then of course, you know, while it's still on the machine, I like to try fitting it in there and see what I get. And so if I'm always getting them loose, then I know, well, actually I shouldn't go to my full depth right away. I should sneak up on it. And you know, you learn by doing it exactly what size your cutter will cut at. Depends a little bit on how sharp it is, and also, you know, whether or not it's the nominal size. But anyway, so I'll set up the cut something like this, and if you want to get repeatably at the same depth or the same height, you know, whatever you'd call this, what I like to do is I like to actually feed over and drop the tool right on the edge. I just touch it off there, and now I have on my quill, I have a digital readout, and this I can zero wherever I want along the 5-inch travel. If you don't have that, you would just have to lock it wherever it is, and now you'd be using the hand crank to lift and lower the table, and you would be using the dial here to tell you exactly how high or low you were, but it's the same idea. I just happen to have this very convenient and awesome add-on on my machine. So I'd crank down, let's say, what does that look like? 300 thousandths. And now I'm going to make my first cut. And now I see people using this all the time where they're feeding in from the end. And that works. But what works a lot better in my experience is to do a climb cut, cutting in this direction. So I'll get over here. And something actually that I like to do also is I can get, just so I get a tooth of the cutter touching my part there. I'm just on it. And now if you have a digital readout or if you have to count hand cranks, either way, you can move over a known value. So I'm going to crank over 500 thousandths. It's 1/2 inch. You know, I'll do 3/8 actually, 375. Lock the table. So now I'm locked in the x-axis, I'm locked in the z-axis. I need to put the spindle into low range. So I want to cut at a very low speed. This is actually at 80 RPMs at my low speed. And I'm going to put just a little bit of cutting oil on my cutter because 4130 steel cuts pretty hard, and these are expensive cutters when you have to replace them. And now by feeding across in this direction, I'm pushing into the cut, and it's just a very stout way to do this operation. Now you could notice during that cut that the cutter is actually eccentric. It's not totally concentric, and some of the teeth do the bulk of the cutting. That's like a fact of life with slitting saws. Good ones, even on good arbors, with a machine with a great spindle, it's going to do that, and you will always sort of hear that to one extent or another with slitting saws. And so when you feed in from the end, what happens is you have a thin wall tube, and in the gullet of the teeth, it wants to catch. The ones that cut the deepest want to catch on that thin wall tubing. But when you cut across this way, it's making more of a sweeping cut. And so each tooth is engaged for a longer part of the cut. And the ones that cut deeper, you can hear them cut deeper, but they don't catch so much because it's more of a sweeping and gradual cut. And that's why I like to cut in this attitude, right? So just feed back across. And now once I'm free, I'm just going to, I'm at 300 thousandths on my digital readout, and I feed down whatever it is, if it's be about 75 or something to get to my thickness. Lock the quill again and just take another cut. So now I just try my dropout and see how it fits, and I didn't even, I was just doing mental math there. It's not even the right thickness, but it actually fits tight. This is actually a pretty decent fit here. And so, I could just do another cut at the same depth. That'd be a spring pass, and it might cut off a little bit more, or I could just bump this down a hair and get to where it had the fit that I wanted. And as you do this over and over again with the same saw, the same tubing, you'll get a pretty good idea of where your cuts need to be. So in terms of things to be aware of with this tool, I would say just, as you're using it, always be mindful that both of these screws are backed out or engaged about the same amount. You don't want this to be tilted way too much, just like the stem on the faceplate of a bicycle or something, right? You want to have it sitting on there pretty square. Another thing I would say is when you're loading it in and out of the machine, especially after you've made some cuts, you're going to have chips around, and you just kind of want to wipe off the face as always, because the aluminum is kind of soft, even with the anodized surface. That makes the skin of it kind of tough, but it's still aluminum, which is a soft material, and so you could be pushing chips in there. So you just always, like any machinist is used to kind of wiping the chips off of the surface with your fingers, and just sort of check for that every time you install it. That'll make sure that you have these nice, smooth, broad contact areas over time. Another thing to be aware of is if you're hot rodding this for larger diameter tubes than it's really intended for, if you're trying to do 3/4 or 7/8 or 1-inch tubes or something in here where it's really designed for the tapered tip end of a seat stay or a chain stay, you might be able to get away with that, but as you extend the screws further, you have less engagement into the block. And so if you're going to do much of that, you may or may not have ideal results because you'll be on the points of the V's rather than on the flats. But regardless, it might be a good idea to switch into longer screws if you're going to try doing that, just so you don't strip out the screws within the block. So make sure to pick up a whole bunch of miter buddies for yourself from the web store. You're going to want one for yourself. You're going to want a couple backups. You're going to want to Let's see, stocking stuffers for friends and families. Imagine this, driving home from work, you're getting pulled over. What kind of police officer couldn't be bribed off with a free miter buddy, right? So you're gonna want to have these around, and just the more the merrier. Thanks for watching the video, and we'll see you around in the shop real soon.